In the last video, we talked about how to solve radical equations. And so we did several examples. So if you need to, take a look at those notes and kind of remind yourself of how they work. But something that I kept mentioning whenever we were doing these problems is it's going to be really important to check your answer. And so after we finished each problem, I had you just kind of quickly go back and plug in what we got for x into the equation to see if it worked out. And so today you're going to learn why I kept doing that. Okay. So today you're going to find out that some of the problems that we do will end up with what are called extraneous solutions, which can happen when you're solving a radical equation at times. So what is an extraneous solution? Well, it's an answer that you're going to get when you've solved the problem correctly. So you're not going to have done anything wrong necessarily, but when you plug it back in, you're going to find out that it ends up not working in the equation. And so we're going to do some problems where you can kind of see that happen. And you'll notice that these problems look a little different than the ones we did yesterday. Okay. So we're going to go right into the examples so you can see how they work. So the thing that's going to be different, you'll notice that a lot of these problems that we do today will actually have an x on both sides of the equation. That's actually going to be one of the factors that kind of plays into why in some of these we'll end up with extraneous solutions. Okay, so just like what you did yesterday, when you're solving these equations, you still have to get the radical by itself. And so notice you have the square root of x minus 3. That's all underneath the radical. Okay, and then you have a plus 5 on the same side of the equals mark. So you've got to get this positive 5 away. So since it's being added, you're going to subtract it. When you subtract it, those will go away. And then on the left side, you end up with the square root of x minus 3. And then those went away. So you just bring down your equals. And then on this side, those won't combine. And so you end up with x minus 5 on that side. All right. So now that you have the radical by itself, now you can get rid of the square root. So remember, the opposite of square rooting is squaring. So we're going to square it so that the radical will go away. And then what you do to one side, you have to do to the other. And so when we do that, the square root and the square will cancel. And I'll be left with x minus 3 on this side. And then on this side, we have x minus 5 squared. So if you remember when we did these problems before, if we have two terms, it's a binomial, and it's being squared, that's where you had to go to the side, write it times itself 2 times, and then you have to double distribute. So if I double distribute, it'd be x times x times negative 5, and then we have to take the negative 5 times x, and then the negative 5 times negative 5. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And then negative 5 times negative 5, a negative times a negative is a positive, and then 5 times 5 is 25. And then the last thing is we just have like terms, so we're going to combine them. And instead of writing it twice, I'm going to write down what I get over here. So over here, I have x squared. The negative 5x minus 5x is negative 10x. And then I bring down my plus 25. Okay. So you'll notice that this problem ends up being just a bit different than the ones yesterday because we have this lovely x squared, which means that this is a quadratic equation. Okay. So to be able to actually finish solving this, we're going to have to think back to all the different ways that we could solve a quadratic. Okay, we could solve it by graphing it. We could solve it by using the quadratic formula. We could solve it by factoring, completing the square. We could use the square root method, but for this one in particular, we can't because we have that bx term. But those are all the different ways to solve it. And we're trying to look for, I guess, the most efficient way. And so I guess for this problem, we'll solve it by graphing because we have Desmos. And so we can very easily graph it on Desmos. And look, remember, the solutions are where it crosses the x-axis. So before I can do that, though, I have to get it equal to 0. So I'm going to get all of this stuff on the other side of the equation so that this ends up being 0. So to do that, I have to subtract my x because it's a positive x. And then I'm also going to multitask, and I'm going to go ahead and add my 3 to both sides. And then remember, what you do to one side, you've got to do to the other. So I'm going to put it with its like term. Okay, so notice I did it to both sides of the equals mark. The x minus x will go away. The negative 3 plus 3 goes away. So you end up with the 0 on this side, which is what I wanted. And then the x squared doesn't have anything to combine with, so it comes down. The negative 10x minus x ends up being negative 11x. And then the 25 plus 3 ends up being plus 28. Okay, so now I can just simply type that in my calculator and graph it and see where it crosses the x-axis. So hopefully my sound won't go out, but I'm going to show you how to do that on Desmos. So let's see if it can. I don't know if it's going to let you see it or not, but we'll see. So you have x, well, you can partially see it at least, squared, and then minus 11x. So I'm just typing it in my Desmos, plus 28. And notice it graphed it for me. Okay, I know it's kind of hard to see, but hopefully you can see the U shape at least a little bit. Okay, and now all I'm going to do is I'm going to click on those two places where it crosses the x-axis. And so, oh, that's a little bit better, at least so you can see the graph. Notice it crosses it at 4 and 7. So I'm just going to copy those down, and those are my answers. So let me pull this away. Okay, so it crossed it at 4 and 7. All right, so that means when I solved that, the x value would either be 4 or 7. And so now this is where you have to actually check your answers. So now I'm going to go back up here and I'm going to plug in both 4 and 7 and see if both of them work in my equation. So I'm going to do it once with the 4. So I'm just going to copy my equation down. That's right here. Okay, so it's the square root of x minus 3. So if I'm plugging in my 4, it'd be 4 minus 3. And then plus 5, and then I'm going to see, is that equal to x? Is it equal to 4 on the other side? Okay, so 4 minus 3 is 1. And then, so the square root of 1 plus 5, does that equal 4? Well, that would be, square root of 1 is 1. Does that work out? Well, this would end up being 6. And so notice that one does not work out. So that means that 4 is what's called an extraneous solution to my problem. So to this side, you would write down that 4 is what's called an extraneous solution because we solved for it and we didn't do anything wrong when we solved for it, but when we plugged it back in, it didn't work. Okay, so now I'm going to do the same thing with 7. So if I take and I plug 7 in, it'd be the square root of 7 minus 3 plus 5, and then we're going to see, is that equal to 7? So 7 minus 3 is 4, so that'd be the square root of 4 plus 5, and we're seeing if it equals 7. So square root of 4 is 2 plus 5. So then that would work. So 7 is actually equal to 7. So the real solution to this problem would be 7, and then 4 is what's called an extraneous solution. Okay. All right, let's do another one so you can see another one in action. So let's say that we have the square root of 3x plus 7 equals x minus 1. And we have to solve that radical equation. Okay, well, notice they were actually kind of nice in this one because our radical is already by itself. And so the next step is you just have to get rid of the square root. So the opposite of square rooting is squaring. So I'm going to square both sides. And then when I square it, my square root and my square will cancel. And so on this side, I end up with 3x plus 7. And then on this side, remember, you've got a binomial and it's being squared. So you have to go to the side and you have to write it twice and double distribute. So x times x is x squared. X times -1 is negative x, or negative 1x. And then the -1 times x is -1x. And then -1 times -1 is +1. Okay, and then combine like terms. And then I'm going to go ahead and write it over here. So we get x squared. Negative x minus x would be -2x. And then I bring my +1 down. All right, just like the other problem, notice this has a x squared in it, which means it is a quadratic problem. Okay, so just the same as the other one, you have all the different ways that you could solve it. You could pick whichever one you want. But for me, graphing it is usually the easier way if I can solve it by graphing. Okay, and so I've got to get it equal to 0. So I'm going to subtract my 3x, and then I have to subtract my 7 to get those off of this side. You got to do the same thing to the other side. So I'm going to put the negative 3x underneath its like term on the other side, and then same thing with the -7. So the 3x minus 3x becomes 0. Same thing with the 7 minus 7. So those go away. So then I end up with 0 on this side. My x squared comes down, and then -2x minus 3x is -5x. And then 1 minus 7 ends up being -6. Okay, so I could graph this. I think that it would also factor, and actually factoring would be an easy thing to do too. So since I showed you how to do the other one with graphing, I'll just show you the factoring for this one. So if we're factoring it, it would be a trinomial thing. So it's a trial and error kind of thing. So you put your 2 parentheses. They don't have a GCF because they don't have anything in common. So then what times what gives me x squared? It'd be x and x. And then remember, if the last sign is a negative, that means the signs are going to be different. So you just put a plus in one and a minus in the other. And then you have to go to the side and write down what multiplies to give you that last number. So we got 6 and 1, we got 2 and 3, and then that's it. Okay. And then you have to kind of start thinking, which of these factors, whenever I combine them with different signs, gives me -5. Well, if you kind of think about it, if I take a -6 plus 1, that gives me -5. So the negative has to go with the 6, and then the positive has to go with the 1. Okay, and then to finish solving it by factoring, you set each of these factors equal to 0. So I take the x plus 1 equals 0, and then I take the x minus 6 equals 0. And so here my x value, if I subtract, I have to subtract 1 to both sides. X would equal -1. And then here I'd have to add 6 to both sides, so x would equal 6. So those are my solutions, okay? So now, just like the other problem, you have to check to make sure that they work. So I'm going to go back to the original problem and plug them both in. So I'm going to start with my -1. So if I'm plugging it into the original equation, it'd be square root of 3 times, I'm plugging in my -1 first. So it'd be 3 times -1 plus 7. And then we're going to see if that's equal to the x minus 1. So that'd be -1 minus 1. Okay, so when I do that, the 3 times -1 ends up being -3. And then -3 plus 7 is 4. So that'd be the square root of 4 on this side. Equals, and then -1 minus 1 ends up being -2. So the square root of 4 is 2. Is that equal to -2? No, it's not. So that means that -1 is what's called an extraneous solution. So that one, even though we solved for it correctly, it will not work if we plug it back in. So that's an extraneous solution. Okay, so then let's check the 6. So it'd be the square root of 3 times, we're plugging in 6 now. plus 7 equals 6 minus 1. Okay, so then let's see what that is equal to. So 3 times 6 is 18. 18 plus 7, that would be 25. And then on this side, 6 minus 1 is 5. And then the square root of 25 is 5. And so does that work? And yes, it does. So that means x equals 6 is actually a real solution that would work in that equation. Okay, so in the problems, they may ask you what is an extraneous solution for this problem. They might say, what is the actual solution to this problem? So you'll have to know how to find both. And then I have one more problem that I want to do with you, just because it's a little different. And so let me get another sheet of paper because I'm kind of out of room. And we will do this problem. Okay, so let's say that we have the square root of 3x equals the square root of x plus 6. So the only reason I wanted to do this one is just because you haven't seen one that has a radical on both sides. And so I just wanted to kind of show you how that worked. If the radical is already by itself, then all you have to do is just simply square both sides. Okay, just like you do once the radical is by itself, you just square both sides. And notice the funny thing here is that because you're square rooting and then you're squaring it, that radical goes away. So you're just left with 3x here. But notice the same thing happens here because you have a square root and then you're squaring it. So that'll actually cancel that out as well. So if you have something like that, it actually makes it a really easy problem. So then from there, you just have to solve. So I got to get my x's together. Since they're on opposite sides of the equals mark, I'm going to have to maybe like subtract this x to get it to the other side. You got to do the opposite. So then those go away. So then 3x minus x ends up being 2x. And then bring down my 6. And then to solve from there, you just divide by 2. And x would equal 3. So pretty quick. But hopefully this helps. Let me know if you have questions. Have a good day.